We're solving the paper May-June 2021, paper 5-2. Okay. Question number 1. An ordinary fair dice is thrown repeatedly until a 5 is obtained, meaning this is geometric distribution. The number of throws taken is denoted by a random variable x. Write down the mean of x. Okay, so the formula for mean of the geometric distribution is 1 over p. It's given in the formula sheet. Now, probability of getting a 5 is 1 over 6. So this would be 1 upon 1 by 6, which is just 6. Find the probability that a 5 is first obtained after the first throw, but before the 8th throw. Okay. So probability 5 is first obtained after the third throw, but before the 8th throw. So this is the inequality. This means that 5 is first obtained on the 4th throw, or on the 5th throw, or on the 6th throw, or on the 7th throw. We know the formula for this. That's also given in the formula sheet. Let me just show you the formula sheet quickly. Okay. Here is geometric distribution. And here's the formula for its mean, and here's the formula for probability. Okay, so from this formula, we know that P4 would be 1 minus P cubed times P, and I prefer Q instead of 1 minus P. So I'm writing Q cubes and then P. Then, sorry, 3 Qs and then a P. This would be 4 Qs, 4 failures, then a P, 5 failures, then a success, and 6 failures, and then a success. Okay, so Q is probability of not getting a 5. That would be 5 upon 6. Probability of getting a 5 is 1 over 6. Okay, now just substitute the values. 5 over 6 cubed times P, 5 over 6 power 4 times P, 5 over 6 power 5 times P, 5 over 6 power 6 times P, which is 0.300 after rounding. Find the probability that a 5 is first obtained in fewer than 10 throws. So probability x is less than 10. The formula that we know is probability x is less than and equals to r is 1 minus qr. So then we'll rewrite this as probability x is less than and equals to 9, which gives 1 minus q9. And q is 5 over 6, which gives 0.806 after rounding. Okay, next. ये हो गया नोट डाउन? Okay. Question 2. Weights of bags of sugar are normally distributed with a mean of 1.04 and a standard deviation of sigma. In a random sample of 2000 bags of sugar, 72 weigh more than 1.10 kg, find the value of sigma, which is the standard deviation. Okay, we have to find probability x is greater than 1.10. We have to find the probability z is greater than 1.10 minus the mean divided by the standard deviation. And we're told that 72 out of 2000 bags have a weight more than 1.1. So this probability is equals to 72 over 2000. Which gives us probability z is greater than 0.06 over sigma is equals to 0.036. Okay, so here's the normal distribution curve. Here's 0 in between. This is the value of z. Greater than 0, there's 50% of probability or 0.5 probability. So when the probability is 0.036, it has to be somewhere over here. So this value of z at the boundary is 0.06 over sigma, and we have to find its value. Okay, we know that the table of normal distribution can only be read when this can be written as phi 0.06 over sigma. And since it's greater than a positive value, you can rewrite this as 1 minus phi 0.06 over sigma equals 0.036. Which means 1 minus 0.036 is equals to phi 0.06 over sigma, which gives 0.964 is equals to phi 0.06 over sigma. Now this is the probability. We find this probability in the normal distribution table and find the z corresponding to that. Okay, 0.964. Let's go to the table. Okay, we need to look for 0.964. 0.9, 6, and 4. So we need to add something here. अच्छा, अब इसमें तो बहुत बड़ी वैल्यू ऐड करनी पड़ेगी. We will need to add 67, and we don't have 67 here anywhere. So I think we'll just use this 0.9641, which is still very close to 0.964. इससे क्या आ रहा है? अच्छा नहीं, आई एम सो सॉरी, इसमें 7 ऐड करने की जरूरत है बस. And we do have 7 here. Okay, sorry, that was a big miscalculation. So if we add 7 to 0.9633, if we add a 7 here in the end, we get 0.964. Okay, so what is the value of z corresponding to this probability? It is 1.798. So this value of z is equals to 1.798. Cross multiply to get the value of sigma will come out to be 0.0334. Okay, next question. On each day that Alexa goes to work, probability that she travels by bus, by train, or by car are zero point 0.4, 0.35, and 0.25. When she arrives, when she travels by bus, probability that she arrives late is 0.55. When she travels by train, probability she arrives late is 0.7. And when she travels by car, the probability that she arrives late is X. I think we should make a probability tree. So arrives by bus or by train or by car. Probabilities are 0.4, 0.35, and 0.25. Probability of getting late through bus is 0.55. That means probability of being on time would be 0.45. Probability of getting late on a train is 0.7. That means being on time is 0.3. Probability of getting late from a car is X. That means probability of being on time through a car is 1 minus X. On a randomly chosen day, when Alexa goes to work, the probability she does not arrive late is 0.48. It does not arrive late means she arrives on time. Okay. Find the value of X. So for this, if she's arriving on time, it could be 0.4 times 0.45 bus and on time, or train and on time, 0.35 times 0.3, or she travels by car and is on time. And the answer is given to us, it is equals to 0.48, or the probability is given to us. Okay, now you make X the subject here. Zero 0.471. Find the probability that Alexa travels to work by train given that she arrives late. Okay, so probability that she travels to work by train given that she is late. So train and late. So we have to find probability that she travels by train and is late. And in the denominator, we're going to find the probability that she is late. Okay, so probability of traveling through train and being late is 0.35 into 0.3 upon probability that she travels late. So we know that probability that she does not arrive late is 0.48. Then the probability that she arrives late would be 1 minus this. So we do 1 minus 0.48 here. This gives 0.471. A face spinner has sides numbered 1, 2, 2. Another face spinner has sides number minus 2, 0, 1. Each spinner is spun. The number on the sides on which a spinner comes to rest is noted. The random variable x is the sum of the numbers for the two spinners. Draw the probability distribution table for x. Okay, before we draw probability distribution table, I'm going to draw a possibility diagram and write down the sums here. So if you get 1 on one of the spinners and minus 2 on the other spinner, then the sum would be minus 1. For 1 and 0, sum would be 1. For 1 and 1, the sum would be 2. Similarly, 0 here, 2 here, 3, and 0, 2, and 3. Okay, now you can draw the probability distribution table X. There, -1 could be an outcome, 0, 1, 2, and 3. These are the all possible sums. Then we write probability x equals x here. Probability of getting a -1 is just 1 by 9. So 1 by 9. Probability of getting a 0 is 2 by 9. Then 1 by 9. Then 3 by 9. And then 2 by 9 again. You can verify your working by adding these up, and this should come out to be 1. Yes, we're getting 9 by 9. That means most likely we got the table right. Next part. Find the expected value of x and variance of x. I'll need the table here, so I'm doing the working. Here, part B, expected value. You just multiply and add the product. So -1 into 1 by 9 plus 0 into 2 by 9 plus 1 into 1 by 9 plus 2 into 3 by 9 plus 3 into 2 by 9, which gives 4/3. For variance, the formula is you square the top value, -1 squared 1 by 9 plus 0 squared 2 by 9 plus 1 squared 1 by 9 plus 2 squared 3 by 9 plus 3 squared 2 by 9 minus mean squared. Which gives 1.78 after you enter this all in the calculator. You have to subtract the mean in the end. So mean came out to be 4 by 3. So for variance, you subtract the mean, the square of the mean, in fact. Okay. This question is done. Question 5. Every day, Richard takes a flight between Aston and Beijing. 1 day probability that the flight arrives early is 0.15, probability that it arrives on time is 0.55, and probability that it arrives late is 0.3. Find the probability that on each of the 3 randomly chosen days, Richard flight does not arrive late. Okay, so what's the probability that arrives late is 0.3. So does not arrive late would be 0.7. So on all 3 days, the probability is the same. This would be the answer. 0.343. Next. Find the probability that for 9 randomly chosen days, Richard flight arrives early at least 3 times. Okay, so we have to find the probability that x is greater than or equals to 3. This is binomial distribution. So we'll do 1 minus probability x equals 0 plus x equals 1 plus x equals to 2. So 1 minus 9C0 probability of success is flight arrives early. What's the probability of flight arriving early? It's 0.15. So P is 0.15 and Q is 0.85. So 0.15 power 0, 0.85 powers 9 minus 0, which is 9, plus 9C1, probability of success power 1, probability of failure power 8, plus 9C2, probability of success power 2, probability of failure power 7. Okay, now find these individual properties, add them in the bracket, and then subtract your answer from 1. Okay, I've already calculated these. Comes out to be 0.231617, then 0.367862, then 0.259667, and the final answer is 0.141. Okay, next part. 60 days are chosen at random. Use an approximation to find the probability that Richard flight arrives early at least 12 times. Okay, approximation means we're going to change binomial distribution to normal distribution. And now we use upper bound or lower bound of the given value. So it says probability that the flight arrives early at least 12 times. So probability X is greater than 12. But if it's the greater than case, then we know Z is greater than 11.5. We take the lower bound for greater than, and we take the upper bound for greater than and equals to. So since this is just greater than, we take the lower bound 11.5 minus the mean over the standard deviation. Okay. Now mean in binomial distribution is NP. N is 60 in this question, and P is probability of arriving early, which is 0.15, which gives 9. Similarly, the standard deviation is square root NPQ. So N is 60, P is 0.15, and Q is 0.85. This gives 2.765. Okay. So now we're going to do P. Z is greater than 11.5 minus 9 over 2.765, which gives probability Z is greater than 0.9039. We need this till 3 decimal places only to read the table. 0.904. Okay, which we know is the same as 1 minus 5, 0.904. So 1 minus, let's find the value of probability when Z is 0.904. Okay. So 0.904. So we add 10 to the end, 0.8159 and 10. So this is what we're getting, 0.8169. So 1 minus 0.8169, which is 0.183. The next is find the total number of different arrangements of the 8 letters in the word tomorrow. Okay, so we have 3 O's and 2 R's. Okay, so 8 arrangements would be 8 factorial over the number of repetition 3 factorial times 2 factorial, which gives 3360. Okay, next is find the total number of different arrangements of the 8 letters in the word tomorrow that have an R at the beginning and R at the end, and in which the 3 O's are not all together. Okay, so there's an R at the front, R at the back. The 3 O's cannot be together, so let's put them on the side and take away R's and take away O's. We're left with three letters, T, M, and W. So T, M, and W would come somewhere over here. So let's first make the arrangements for R. These are two R's on two slots, so 2 factorial times, and now we have T, M, or R in one of these places, so that's 3 factorial or 3p3. And then we have O, and O either here, 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 or here, so that they're not together. These are 5 slots for 3 O's, so 5p3. Sorry, 4 slots for 3 O's, so 4p3. Divided by the repetitions, we had 2 R's and 3 O's. Solve this to get your answer. It's just 4p3, which is 24. Okay. 4 letters are selected at random from the 8 letters of the word tomorrow. Find the probability that the selection contains at least one R and at least one O. Acha. Whenever there's a question on probability and combinations, we have to use a different strategy. That strategy is that you give numbers to all these O's and R's. The repetition values, we have 3 O's, so let's call them O1, O2, and O3. And we have 2 R's, let's call them R1 and R2. And then we have a T and an M and a W. The O's are treated as 3 different O's, and the R's are treated as 3 different R's. Find the probability that the selection contains at least one R and at least one O. So 4 values are being selected, 4 letters. One of the case would be you get an R, you get an O, and you get 2 other values. Then one case would be you get an R, and then you get 2 O's and 1 other letter, or an R and 3 O's. Okay. Or 2 R's and 1 O, or 2 R's and 2 O's. So I think we got everything. Okay, now let's write down the number of combinations. Okay, now this is how it differs from a usual case of selection. अगर probability नहीं होती इधर, if probability was not mentioned in the question, then here we would just do, we have 3 letters left, T, M, and W, and 2 slots left. So we would have done just 3C2. But now what we'll do, since we're treating the R separately, we're going to say there's one slot for the 2 R's. So we write 2C1. Then there are 3 O's and there's only one slot for it, so 3C1. And then there are 3 other letters and 2 slots for them, so 3C2. 2C1 times 3C1 times 3C2, which gives 18. Okay, for second one, there are 2 R's and 1 got selected, so 2C1. Then there are 3 O's, only 2 got selected, so 3C2. And then there are 3 more letters, but only 1 will get selected. This also gives 18. Then we have 2C1. There are 2 R's, but 1 got selected. And then there are 3 3's and all 3 of them got selected. So 2C1 times 3C3, which gives 2. Then again we have 2C2 times 3C1 times 3C1, which is 9. And then we have 2C2 times 3C2, which is 3. Add these up and you get 50. So probability is desired outcomes over total outcomes. Desired outcomes are 50. Total outcomes are uh, unrestricted case where any 4 are being chosen. So 8C4. Denominator is you choose any 4 out of these 8. So 8C4. So we have 50 over 70, which is 5 by 7. The last question देख लेते हैं. Let's go fast because the recording is ending in 6 minutes. थोड़ा जल्दी जल्दी करते हैं. State an advantage of using a stem and leaf diagram as compared to box and whisker. So in stem and leaf diagram, you can see all the data values, but in box and whisker, you can only see the lowest most value, the lower quartile, and the median, the upper quartile, and the highest most value. So you write original data is retained in stem and leaf. Represent the data by drawing a back-to-back stem and leaf diagram for Amazons on the left side of the diagram. Okay, so let me just draw it here. I'm going to do the working for part B right here. So Amazons need to be on the left. In between, we'll have the stems. And on one side, we'll have the giants. Okay. The stems would be 17, 18, 19, 20, 21. The smallest most value in Amazons is 178. So we write an 8 here. Nothing else in 70s. And then in 18s, we have 1, 2, and 4. Then 0, 6, and 8 for 190, 196, and 198. And then we have 1, 2, 5 with 20. And then we have 5 with 21. Similarly, for giants, we have a 5 here. We have 2, 4, 7, and 9 here. Then we have 2, 3, 5, 5, 5 here. Then 24 here, and nothing in the 21 range. Okay. So we've made a stem and leaf diagram. Next part says, find the interquartile range for the heights of players in Amazon. Okay, so we need the interquartile range here. So first we need the median, which value is in the middle. 1, 2, 3, 4, 1, 1, 2, 3, 4, 1, 2, 3, 4, 1, and 1. So I've established, oh, I did not write the key with the stem and leaf. I'll lose marks here. Anyway, I remember that this is the median. Already calculated. Okay, so the key would be, you can write this 0 slash 19 slash 2 means 190 centimeter height for Amazons, and similarly 192 centimeter height for the giants. Okay, you can complete the key. Remember, the key must be there to get the 1 mark for this question. Okay, so we found the median. It is 196, but they've asked for the upper and the lower quartile. So for that, we now need the center of these upper 4 data values. The center here would be, these are in fact 1, 2, 3, 4, 5, 5 data values. So this is the upper quartile, and the third value from the start, and the third value from the end would be the lower quartile. So upper quartile is coming out to be 202, and lower quartile is coming out to be 182. And the difference of these would be the interquartile range, which is 20. Okay. Last part says that 4 new players joined the Amazons. The mean height of the 15 players in Amazon is now 191.2. The height of the 3 new players are 180, 185, and 190. Find the height of the 4th player. Okay, so we already know the mean 161.2. So what and we also have the height of the 3 new players. So we can use X for the 4th player and use the mean formula. Okay, so we have 178 plus 181 plus 182 plus 184 plus 190 plus 196 plus 198, then plus 201 plus 202 plus 205 plus 215. Three more data values have been given in the question, which are 180, 185, and 190. So 180, 185, and 190, and the last one would be X. Now these total data values would be, add them all up, add plus X to it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These are now a total of 15 data values. So divide by 15, and the answer, the mean is, what is the mean? The mean given is 191.2. So is equals to 191.2. So you simplify all of this in the calculator, add X to it, divide by 15, and equate it to 191.2. When you solve this, you get X is equals to 181. Okay, that brings us to the end of the paper.